Okay, this is Mrs. Davis again, and I'm gonna just double check we are recording. Okay, um, so this is the third video for sections 113 and 114, and the other two videos walk you through how to create a residual plot by hand, and now I'm going to show you on your calculator how to actually do it on the calculator. And these are really good instructions that are written in your notes, but I'll walk through them with you, okay? So let me make sure you can see the whole calculator here. Put this here. Okay, get it. Okay. Okay, so the first thing we want to do this residual plot, let me get out of there, is you still have to have your function all figured out. You had to do your regression and get a regression model and save it in Y1. And so now, say you want to do a residual plot with your calculator, because it was a pain doing it by hand. So what the first thing you're going to do is go to the stat plot menu. So if you go second stat plot, okay, let me show you that. All right, so again, it was second y equals, get you stat plot. It says stat plot up there. So okay, so you're going to hit enter to do your first plot. Now this is usually off, so if it's off, turn it on. And then go down. The next one is like what type, and we want the little dots. That's the easiest thing. And then if you go to X list, that's list 1, and then Y list for a residual plot, you're going to want the residual. You want to want the residual. So if you look at your calculator, there's a list right here under stat, and that's where the lines will L1, L2, etc. will reside. So if you say second stat or list, you want to go down to 7, and now it says residual, and make sure it's in the Y list, okay? And then you can have a square mark or a plus mark, and then you can do your color. So if you have a color one that goes color computer, calculator. All right, and so you just get out of that now. Okay, and then let's see, it should look like this. This is really nice. It shows you exactly what your calculator should look like. So let's turn the page and go to the next page of the notes, which goes through it. Okay, so now you want to graph the residual plot. So if you hit graph, there's your line of best fit. And now if you want to see that plot better, you go zoom and 9, zoom stat, and you hit enter, and there it is. There is your residual plot. And so you can see it's the same numbers we had, 2 below and then 1 up high, and then these two. You can see it's kind of the same shape. So it gives you a good idea of basically there's the same number top and bottom about, and there's no crazy curve or something where they're all going down or they're all going up or they're all below, which means it tells us it's a pretty good line of best fit. All right, so you have the directions for doing that on the notes, but you also just saw me do it, so hopefully that helped you do it. All right, now let's go on to example 5 in our notes. All right, we have a new example, and we have 8 ordered pairs, and it wants to know which function best models the data in the table, linear, quadratic, cubic, or rational, and explain your answer. So what you can do is go through each regression model and look for the one that has the best table, but actually it might be faster if we just kind of look at the data. So if we're not using our calculator, we can see that as the X values increase, the Y values go 5, 10, 15, 17, so they're going up to 18, but then they start down at 16 to 10 to 2. So I would say, if I were to make a guess, that a quadratic model would be good here. So I wrote as X increases, Y increases, and then decreases. So we're going to check with our making a quadratic and look at our line of regression again. All right, so let's put our data in. Okay, so we have to create a new list. All right, so let me do this down here. And so do it with me. I can't stop the video, so you're just going to have to bear with me putting in these numbers. Okay, so go up and clear. So it's 0, 0.4, 0.9, 1.2, 1.7, 2.2, 2.9, and 3.4. So double check 0.4, 0.9, 1.2, 1.7, 2.2, 2.9, 3.5. It's good to check as you go, because if you get the wrong data in, you're going to get the wrong line, and then everything will be wrong. So it's good to double check. So under Y value, I have 5, 10.6, 15.4, 17.1, 2.2. It's not 17.1. I was looking, okay, yeah, I'm okay. 5, 10.6, 15.4, 17.1, and then 18. I got off a little bit. And then 16.5, and then 10.2, and then 2.8. So again, check these. 5, 10.6, 15.4, 17.1, 18, 16.5, 10.2, and 2.8. Okay, so I got my data in there right. So now remember, we go to Stat, go up here, Stat, and we go over to Calc, and this time we're going to look at 5 right up here, quadratic regression, because we think that's a good model. So put in 5. Now remember L1, L2, and remember how to store this. Okay, you would go second trace, nope, second alpha trace, sorry. So quit alpha trace and get your Y1. But I'm out, okay, I'm now out of my regression, so I got to start again. So Stat, Calc, and then 5, and then go down here, and then it's alpha trace to get my Y1, and then hit calculate. All right, so I have my regression model here, and remember, it gives you in standard form, ax squared plus bx plus c. So your a, b, and c are given to you. And I'm glancing down here at this r squared, so I can see it's going to be very, very good. If it's close to 1, remember, it's a very good model. So I did kind of pick the right one. Okay, so if we look at our calculator and then our equation, what we had in our calculator, we had y equals, and a was negative 4.88317. Now I'm going all the way out, as you know, what did I do? 1, 2, 3, 4, 5, just to give a really good equation. X squared, because the more you round it, the further off it'll be. Plus 15,9,580, and I could have put an 804 to be consistent to be 5. X plus 4, C is 4.99564. All right, so that's the equation for the regression model for that. All right, so that was example 5. Let's look at example 6. All right, example 6 says we have this data, order pairs, use a logarithmic regression, okay, construct a natural log function, f for y, as a function of x, and then write it in the form a plus b ln x, where a and b are constants. So we have to go back and we have to put this data in to our calculator again. Okay, so bear with me one more time. We're just doing this as we go. So let's get our data in there. So stat edit, go up and clear, go over and up and clear. And let's put these numbers in. 0.3, 1.6, 3.2, 4.7, 7.1, 8.8, and 10.3. Okay, so double check. 88, 71, 47, 32, 16, and 0.3. And then under Y, I have go over here, 0.9, 3.3, 4.9, 5.7, 6.5, 7, and 7.1. Okay, so double check, 7.1, 7, 6.5, 5.7, 4.9, 3.3, and 0.9. All right, so I've got all my data in correctly. So now I want to go, let's do stat calc again, and this time you're going down to LN regression, so 9, and you hit L1, L2, okay, and now let's remember it's alpha trace to get our Y1, and then we're going to hit calculate, and you can see it's y equals a plus b ln x, and so we have a and b. So if we write that out over here, you get f of x equals, you should have gotten, if you look here, 2.86363 plus 1.818 0.41845 ln x. So there's your equation that you should have gotten from your calculator. Okay, now it says in part 2, the residual plot is provided. What are the coordinates of the labeled r on the residual plot? So so if you look at 1.6, they're giving you the first, it looks like this would be the first one, that would be the 0.31. And so it's this r is the second one, which would be your 1.6. So how do you know what point that is? Well, remember back, it's residual minus predicted, right? So the residual is the actual minus the predicted. So the actual up here was 3.3, and my residual would be if I put in 0.3 into my function. So let's go again to get our y1, and I want to put in 1.6. And so this is going to be using my equation to tell me what it is at 1.6 instead of the actual. And it comes out to be 3.71831. So if I do actual minus predicted, I get negative 0.41. So I can do that now. Let's do it. 3.3 minus 3.71831. And you get negative 0.41831. All right, and so that's what they asked you to do. But it said, what are the coordinates of it? So the coordinates would be your x value, 1.6, and then there's your residual. So that would be down here. That point is that point right there. Okay, and part 3 says, does the residual for point R indicate that the model F underestimates or overestimates the value of y at that? Now, if the residual is negative, that means the predicted value is an overestimate, and you can see up here the predicted value was larger than. So if you get negative, it's going to be an overestimate. Okay, and that's what we would answer that question like. All right, let's see. Let's look at comparing models, this next equation. Now, I think I've worked enough with you on the calculator. So let's just talk about this, and you guys can put this data in yourself. So we want to use a calculator to find a linear model, a quadratic model, and a cubic model for this data. Okay, so here's our data. You're going to put in this data into your calculator. Under the L1, this would be L1, and this would be L2. All right, so if you put that all in, and you hit linear regression, this should be the equation you get. So do that and check that that's the equation you got. And then the quadratic model, you would have to just go back and do stat calc and pick quadratic now, and you should have gotten this one. Okay, 0.05942 x squared minus 0.61657x plus this little number down here, 8.31143. So that's the quadratic model. And now the cubic model is this number. We have it all worked out here. So it's a cubic, goes to square, then x, then constant. Okay, so it says which which model appears to be the best data fit? Explain. Okay, so I'm going to stop this video there, and I'm going to pick up here because I want to show you, after you get your data in, how you can look at your model and kind of see how close your model is to the actual data points. And so you can tell I kind of plotted out the residuals and what they look like, and you can tell that the cubic ones are closer if you kind of look at them. I kind of wrote them here for my notes. You can see that they're closer than the cubic one is the closest one, so that's the best model. Okay, so I'm going to stop here, and the next video will hopefully finish up the lesson. Okay.